right here. So the reason that we need to look at this picture is because this is allowing us to simplify these equations that we're using to find the surface area of all of these prisms. So it says a right triangular prism, a right rectangular prism, and a right pentagonal prism are pictured below and all have equal heights of h. Part A says to write an expression that represents the lateral area of the right triangular prism as the sum of the areas of its lateral faces. So when we think of lateral, so I'm going to use an example of the body. So when we're talking about the body, lateral means off to the side. So what they're asking us to do in terms of these prisms is to use the sides of the prisms in order to write an expression that represents the area of the prism. So we're going to look at the first prism here, and it's a triangular prism. And what we need to do is make sure that we're combining each side of this prism with the height, because we know that we find the area of a prism by length times width. So we're going to look at the each side and multiply it by the height. So length would be the height. Okay, so we're looking at the right triangular prism first. So we have side A, and we're going to multiply side A by the height. And we're going to multiply side B by the height. And we're going to multiply base C by the height. So that is how we would find the area, the surface area of that triangular prism, by multiplying each of those sides by the height and then adding them all up together. So that's pretty much exactly what we did if we were to go back and look at our previous example when we found the surface area of the right triangular prism. We multiplied every single side of that prism by the height in order to determine the surface area. So that's what we're doing in this right triangular prism here as well. I'm going to need to move up, and that's going to stay right there. So I'm going to move up to right here. And what we're looking at now is the surface area of that, the right rectangular prism. So now we're looking at this one right here, the middle one. So instead of moving up, I'm just going to write it above. So what we would do is we would look at the surface area and we would say, well, we're going to multiply A times H, and we're going to multiply B times H. But we all actually have a lot more A's and B's than what we just said. So we actually need to multiply one more time, A times H, because we have a top here, so that's A. And we need to multiply one more time, B times H, because we have another side here, and that's also B. So that would be how we would find the surface area of the right rectangular prism. Now let's take a look at the pentagonal prism, because our last question says, oh, it's on the next slide. Our last question is going to say, write an expression that represents the lateral area of the right pentagonal prism as the sum of the areas of its lateral faces. So notice that here at the front, we have a rectangle. So here's the front of this pentagonal prism. So we've got A times the height, because remember, length times width, plus we have another side right here, and it's B times the height, so B times the height. And then we have C times the height, plus C times the height, plus, you can see the pattern here, D times the height, plus E times the height. So now you see that this is how we would find the surface area of all of these prisms. Now, I'm going to flip ahead to the next slide because they ask us, so I could rewrite this. So this is the right pentagonal prism. And so we did A times H plus B times H plus C times H plus D times H plus E times H. And what I wanted to take a look at was this part D here. And part D says, what value appears often in each expression and why? So if we were to go back and look at this slide here, we notice that there's an H in each of these three expressions. For the triangular prism, we use the height. For the rectangular prism, we use the height. And for the pentagonal prism, we use the height. So the value that appears the most often is H, and it's because it's the height of each of these shapes. So then when we are looking at part E, they ask us to rewrite each expression in factored form using the distributive property and the height of each lateral face. So remember, with the distributive property, we pull something that is constant out of the equation so that we can simplify the equation a little bit easier. So I don't have a ton of room here, so I'm actually going to go back. And we're going to look at this first problem. And so we see that there's an H right here in our problem, there's an H right here, and there's an H right here. So we can use the distributive property and pull out that H. We would put the H in front of our parentheses and put what's left from our equation inside the parentheses. So I notice that I still have an A, a B, and a C left. So I've got H times A plus B plus C. And if I were to use the distributive property, I would get the same equation over again. So that is us using the distributive property to rewrite this equation into a little bit simpler of a form. And we talked about distributive property a couple of lessons ago. So we're going to do the same thing for the right rectangular prism. So I see that I have an A, I have a B, I have another A and another B, but I can pull an H out. So now I have H multiplied by A plus B plus A plus B. And I know that I can simplify that even further because what I actually have is two A's and two B's. So if I add those up, I get 2A plus 2B. So I'm going to erase this and represent it just like that. So I've actually got H multiplied by 2A plus 2B. And if I were to use my distributive property, I would end up with the exact same equation that I had up here. So now, because I have a little bit of room on my next slide, I'm going to look at this the pentagonal prism. And I see that I have an A, a B, a C, a D, an E, but I have a constant of H. So I can represent the surface area of this pentagonal prism as H multiplied by A plus B plus C plus D plus E. And I would use my distributive property and multiply this H into this equation, and I would get the same thing that I had before. There we go, the same thing that I had before. So we just rewrote each expression in factored form using the distributive property, meaning we were able to pull out a constant or something that we found in each of those equations multiple times, put it in front of our parentheses, and simplify that expression. So we did that. So now we're going to take a look at part F. And part F says, what do the parentheses in each case represent with respect to the right prisms? So let's go back and take a look at our first slide. So we see here, and we're thinking to ourselves, how would we find the perimeter of a triangle? And we would simply find the perimeter of a triangle. So remember, the perimeter is the outside of the triangle. And we would find the perimeter of that triangle by just adding up all of those sides. So what we see inside of our parentheses is the perimeter of that triangle. We would find the perimeter by adding up A plus B plus C, and that would give us the perimeter or the outside of our triangle, of our triangular prism. Okay, so let's take a look at the next one. So if we were going to find the area of a rectangle, we find the area of a rectangle as 2 times A plus 2 times B, or 2 times the length and 2 times the width. That's how we find the perimeter. So what we're seeing is that this right here, inside of the parentheses, is the perimeter of a rectangle. Okay, so we're seeing this pattern here. We pulled out an H, and now inside of our parentheses is the formula that we would need to find the perimeter of each of these shapes, each of these prisms. Let's look at it one more time. So if we were to find the perimeter of this pentagonal prism, we would add up all of those side lengths. So all of these side lengths right here are added up, and this is the perimeter. So they ask us, what do the parentheses in each case represent with respect to the right prism? They represent the perimeter of the right prism. So they represent the perimeter of the right prism. So what we're seeing is that inside the parentheses is the way that we would find the perimeter of that right prism. So there's a way that we can generalize the lateral area of a right prism into a formula that applies to every single right prism. And it's pretty simple. So we write this formula as the lateral area, or the lateral area, the area of the outside of each of the prisms, is equal to the perimeter of the base times the height. And we're going to take a look at this in a lot more detail in our next lesson. We're not going to do it so much today, but I want you guys to understand that we would find the area of this lateral prism. We would find the lateral area of these prisms simply by finding the perimeter of the base and multiplying it by the height. That's what we're saying. We can generalize it into a simple formula such as this one right here. So I need to go through just one more thing with you guys, and then I want to explain to you the homework and the problem set, or I'm sorry, the exit ticket and problem set, and then we'll be done for today. So I'm going to flip ahead to my next slide, and it gives us some relevant vocabulary. And I know we don't always go through this relevant vocabulary, but I want to do it today because I want to make sure that you guys understand the prisms, the different types of prisms. So a right prism is when we have two parallel lines, and we either have a triangular region or a rectangular region that's connecting those two parallel lines. So we see here, let's see, so we've either got a rectangle in the middle of those two lines, or we've got a triangle in the middle of those two lines. So a cube is a right rectangular prism, all of whose edges are of equal length. So a cube is as if we were looking at a rectangle. And then when we're talking about the surface of a prism, it's the union of all of the faces. So we're looking at all of the faces combined together, and that's our surface. Okay? And then a net is a two-dimensional diagram of the surface of a prism, meaning we've separated all of those sides of the prism and we've laid them flat on the ground. And so now we're looking at a flat example of a prism. So I really wanted you guys to just understand that vocabulary. And now, before